And so for nearly 3 billion years, the first 3 billion years of Earth's existence, it was nothing but just fluid, super hot material. And so it was just to think about a volcano, but it was just large areas would have just been this molted in this liquidy but super hot surface. But over time, that surface that was very hot and liquidy hardens. And so today we can see this. This is that bottom layer. And so this is the most underlying layer of our bedrock that formed over billions and billions of years, but formed a long, long time ago. Then, over time, this is kind of hard to fathom, but Indiana was actually, where we are today, was actually the bottom of a very shallow sea. And so in that shallow sea, so much aquatic life lived. I mean, we've got all the different creatures that might have lived, from unicellular organisms to multicellular organisms. So then you got all the carcasses of everything that ever lived over millions and millions of years in this shallow sea that was full of coral, full of aquatic life. And so everything everything eventually turns to dust and falls back to the ground. And so in the case of all the living creatures that lived in the shallow sea, they eventually, their carcasses, their shells, eventually fall to the bottom. And then after millions and millions of years, after carcasses and shells continue to pile on top, what ends up happening is you got compaction, but hardening of that material. And that's a sedimentary rock we call limestone. And so over time, the fact that Indiana was at the base of a shallow sea, we have this limestone. And this limestone is on top of that underlying bedrock, that underlying igneous rock formed from the billions of years of Earth, of that liquidy material hardening and then providing that what we call that basement or that bottom layer of our underlying crustal bedrock. And so this is very hard to understand, very hard to visualize, but right in the crosshairs, right in the center of this image, if you look just to the right and just a little up from that dead center, you'll see a shallow sea, and that was where Indiana is. And so what you also will notice, these mountain ranges just to the south of that shallow sea are the Appalachian Mountains, which formed as Northwest Africa. In the United States today, we're bumping up against each other, and that bumping up against each other created those mountain ranges that today are one of the oldest mountain ranges in the world. Just a few blocks from IUPUI's campus is the Indiana State Capitol building, which is made of using Indiana limestone. One thing you'll notice, the softness of the stone allows the very ornate architecture and sculptures that we see around the windows and the pillars and all of that. That's why limestone is so desirable. It's soft enough to be carved, but obviously sturdy enough to be a nice sturdy rock for a building. Many buildings on IUPUI's campus utilize Indiana limestone, including the new law building. The National Cathedral in Washington, D.C. used entirely of Indiana limestone. The Empire State Building, Indiana limestone. The Pentagon, Indiana limestone. Historically, Chicago had a big fire. It wiped out a lot of their buildings. A lot of their buildings were then rebuilt after this fire utilizing Indiana limestone. The movie Breaking Away, for those of you old enough to remember this movie, has this scene of a quarry just south of the Bloomington campus. And a lot of you, if you've ever been down there, you've seen these big, huge limestone quarries in which you maybe can jump in, or if you want to get rid of a car, a good way to get rid of a car is just to dump it in one of these big quarries. And one of the things it showcases the limestone that's being mined in this area of the state, south central Indiana, overwhelmingly. The old Yankee Stadium and the new Yankee Stadium, Indiana limestone. And this makes sense, the fact we have this limestone and this further deeper down layer of igneous rock that formed from the 3 billion to 4 billion years of Earth's early existence, and that magma eventually hardens, and that's showcased here in this black rock at the bottom. But then we have uplift, and so that uplift created from the Appalachian Mountains forming. And so what was today, or what Indiana was historically at the bottom of a shallow sea, because you had plates converging on other sides and far away from Indiana, what it ended up causing was it caused uplift. And so it caused all this rock to rise. And so as it rose, what ended up happening was it rose above sea level. And so now we have this rock that's above sea level, and then we can go to the next slides to explain the next layers that are on top of this Indiana bedrock. And this is now illustrating the uplift that occurred, and now that put that shallow sea, which had all that limestone, is now above the sea level. So then that makes it now capable of being weathered and eroded, all the various things we're going to talk about in the remaining parts of this supplemental video. One of the things, if you flip back and look at that previous slide, is it shows Indiana essentially right there at the equator. And so that means it was very much in an area of tropical rainforest, which has a ton of rain. And a ton of rain and a ton of sun, like we've showcased before regarding tropical rainforest, is going to produce a ton of vegetation. And so the vegetation that you saw overwhelmingly here, because Indiana was in a quite tropical area, was the same kind of rainforest you'd see in the Amazon today, or in equatorial Africa. And so you had a ton of living things, and a ton of those living things, of course, died. And you've got this material very rich in organic matter. And so you got all these trees, all the leaves, everything that ever lived in this area, keep in mind, millions and millions of years, as a tropical rainforest, then eventually leaves this layer of an organic rich material which continues to build on top of that material over time. So think about Indiana being a rainforest, a swampy area. All that vegetation eventually decomposes, but then continues to layer on top of more decomposed material. And so that continued decomposed layer after layer then leaves behind this other natural resource that we're going to talk about in the next few slides. And so this brown is trying to illustrate that organic material, as Indiana was at this rainforest, tropical rainforest area. And so all that material, all that organic stuff, then eventually decomposes, and we can illustrate that here with this brown layer. And that brown layer then over time metamorphosizes, so it changes its characteristics. And so with temperature, with pressure, with various things you'll learn in geology class, what ends up happening is that organic rich material becomes coal, becomes oil. And so one of the things about oil is it takes millions and millions of years to form. So this material here, this layer, eventually gets buried under other layers of sediment, and then of course becomes capable of being mined as we have techniques to go down and probe and access that coal or access that oil.